Hi, Mommy. You're live. All right. It is vital that we are understanding how to write these ionic formulas. And what we're going to find out, because of these notes and the notes we took previously, that an ionic compound, and this is one of the key concepts, after the ions have done their thing, is always going to be, from the outside looking in, a neutral compound. In other words, the amount of positive charge and the amount of negative charge is going to be equal. Now, we saw that very easily in table salt, Na with Cl. And if I asked you, what are these Lewis dot structures? Well, Na is in the first group. How many valence electrons? Chlorine's in the 17th group. How many valence electrons? 7. And again, we put them in unpaired first, then we pair them up, and we could see very easily, yes, if sodium were to lose its 1 electron, it would be happy because it looks like neon now. It has 8. It is a positive ion with no dots around it. That has 8 valence electrons. And now all of a sudden, chlorine is very easily seen as having 8 because it has gained that extra electron and has become negatively charged. And that's 1 minus and 1 plus. That cancels out. This is neutral, and they stick together because opposites attract. All right, Briella, question first.
Put this on your desk. It's my whodunit thing.
It is your what a hootie?
Exactly.
Yeah, exactly.
Is it something you needed to turn in?
Yes.
Well, thank you for remembering. It's awesome.
No, she should get a perfect score.
Jack.
Yeah, I should.
Does the electron for chlorine have to come from sodium?
Well, obviously not, because chlorine can form numerous amounts of ionic compounds with other metals.
Yeah.
But, as we're going to see, this is why we're recording today, we're going to have to understand how to get there. And so we're going to go through it, attack it in 2 ways. Way 1, the concept. Way 2, the method in order to do it.
Okay. But I mean, like,
And we have a lot of talking.
Yeah, my bad.
could they still
They
bond?
say, yep, my bad. But what does that actually mean?
I said he did.
So, like,
I talked to him, so.
Yeah,
would they
but-
still bond even if sodium lost its electron to a different atom of chlorine and chlorine gained its electron
Well,
from?
you got to remember, environment's important. So sodium is going to give the electron to what's around, and then they'll bond, whatever that is.
Wait, this makes sense now.
In the case of table salt, when chlorine's around, especially on Earth, we saw how explosive this was yesterday. Like, if they're together, they,
Combust.
yeah, it looks like a combustion, but it's not. They react. And it reacts with fire and heat and light and
Violence.
yes, you do not need oxygen for this though. You can seal that container, that's the difference. Combustion has to have oxygen. You can seal that container, if sodium's around chlorine, boom, and you have table salt. And remember, these are new compounds with new chemical formulas. In fact, we already talked about it. Lick it, die, right?
Yeah.
Yeah.
But yet, together, we put it on pretty much everything we eat.
Let's go.
It's just vital.
And we can explode it.
Yeah, it's an electrolyte you absolutely need. Table
Wait.
salt is a necessary thing.
So if I
All
do
right.
this, can I explode it inside me?
Oh, jeez.
Like, just like
Or if you
metaphorical question.
Why don't we just already take it in its combined form and not try to somehow ingest sodium, and
No,
But if
which
you're-
will blow up in your
But yeah,
face?
if you're in a war
Challenge.
zone and you get chlorine gas,
No.
you just ingest sodium.
Yeah.
Dude, you're so
All right.
You're so
Well,
smart.
here's the
Oh my
thing,
gosh.
when you do it, put it in your mouth, it's gonna explode.
I like the theoreticals.
Just throw it in the gas.
All right. These 7 polyatomic ions you have to know. Name, formula, and charge. In fact, your Rocky,
Sorry.
you said that
I
last
know,
time.
I know.
My
I'm
bad.
Caught
always
you on
down
video,
for it.
too.
Sorry.
This is gonna be a great video.
Oh, is that correct? Sorry.
You should make it go public. It's important.
Yeah,
What's
sorry.
really?
Last year.
It's definitely gonna be public
Reality.
enough for
Would've been better
you.
if you wore a costume.
It'd be. I am in costume. I'm dressed up as your
No
kind of
way.
food.
You
People
should have
used
dressed
that
up
one
as
for
Carter.
years.
Did you get it? Funny.
All right.
Okay.
On Thursday, your job is to make flashcards of these polyatomic ions. I think for both visual and motor learners, that's a good concept. Now, for those of you that are auditory learners, you're going to have someone like call them out to you, or you're going to have to call them out to yourself, or look at yourself in the mirror and do it. I have no idea.
That's a lot
Whatever
in.
makes it click,
What are you doing? Nothing.
because I'm going to tell you this. You will have quizzes on these next week. It's guaranteed. In fact, I know it's on the lesson plan. And all you need to do is write them. Name, formula, and charge. So what you need to do to get that in your brain, you've got to have those 7. Again, we're not going to go over all of the polyatomic ions. In fact, if we were given other polyatomic ions, I'll give you those formulas. In fact, I'll put a slide up today that will have a bunch of them on there. That way we should be able to do all of them. But will you need to memorize all of those? No. But sulfate and phosphate and hydroxide, these are in so many chemicals, it's crazy. You need to know them. You need to know their formulas immediately. So did anyone actually go home and try to learn those already? I'd probably say no because you were studying for a test, but if I did say sulfate, what would anyone remember sulfate from yesterday?
Yes, that's ionized
Sulfur with 4 oxygen atoms, and this has a 2- charge. Very good. I like what I hear. All right, let's carry this in, because now we're going to get this whole kind of concept hopefully down pat. Because the vast majority of ionic compounds that we interact with, in fact, pretty much most, if not all, I guess there's some things that could technically be ionic that aren't binary, but it's my guess that the compounds you see are binary ionic compounds. Which means what? Well, it just means that any cation can bond with any anion. Binary means 2. So a cation is one of them, a positive ion. The anion is the second one, the negative ion. And so
what would that do?
that
Make a new
makes sense.
compound?
Well, of course, these are all going to be new.
Okay. Interesting.
They form what's called a binary ionic compound. Also, we have other names for ionic compounds that was in your notes. And again, I understand you were probably really focused on lectures 4 and 5 last night, but does anybody remember the other names for ionic compounds? Ionic compounds can be called salts, or they can be called formula units.
And then ionic sulfur. Oh, wait,
All right, so nothing really new here, which is good.
29. Who's asking a question?
Who was asking?
He asked if it was a 29. And I said yes.
Today is
29.
the 29th.
Once.
And we already see this example. We've had it on the board already, even this morning. Table salt is a ionic compound. All right, excellent. So the ratios of these involved is the big deal. And we're going to see why here in a millisecond. Well, it's going to be more than a millisecond.
Yeah, 100,000
As soon as you said the word millisecond, it was already a lie.
Correct. It took much longer than a millisecond to say millisecond.
I love how the smallest things can have some of the longest names. Hey! I don't know why I said it like that.
Who can tell me what a ratio is? If the ratio is the big deal, what is a ratio?
How much of one thing is equivalent to another?
Very good. I'll tell you, Wednesday's on it today.
Can you not? Can you
Because it's
Well,
Wednesday.
it is
It is
Wednesday.
Wednesday, but it's.
You are Wednesday.
Oh,
All right.
gosh.
But
I'm good on Wednesday.
It is how one thing numerically compares to another thing. And so for table salt, what is the ratio between the two ions that makes it happy?
8? No. What?
Yes.
1 to 1.
1 to 1. For every one sodium atom, it makes one chlorine atom happy. They're equal. And notice the charge from the outside looking in, -1 plus +1 equals
Neutral.
0. And that's how a binary ionic compound should look. So when we go into this idea in chemistry is called now an empirical formula. So an empirical formula is the ratio of atoms.
It's imperial.
Empirical.
Oh.
It is the ratio of atoms
Why do they call it that?
of elements in a compound. Huh?
Why do they call it that of all things they could call
I don't know. I wasn't there during the naming of this.
You should ask them.
But I do believe that empirical does have a mathematical definition
it? Okay.
that refers to that. Yes, Briella.
Is the EX, is that example or is it actually something?
That's example.
Okay.
Good question. Yes.
Is the, like, I don't know what to call it, but the amount of electrons that are missing or added to an atom, does that affect, like, is that a factor in the ratio?
Absolutely. So we're going to find out with the upcoming example. That is a really big deal. All right. So again, the empirical formula is the ratio of elements that are included in the compound. And as your math teachers have always done, all ratios have to be what? They can't be equal, or they can be, but they don't have to be equal. But they all have to be this, though.
You have to have two sides to have it.
They're numbers. They've got to be a real number. Yes, that's true. You're not going to do ratios and decimal points, even in chemistry. I like that. Now, in math, I'm sure you could get to some ratios that are in decimals, but they usually have your ratios nice. But in chemistry, we don't talk about half atoms. Got it? So we definitely want whole numbers. All right, I like that. But there's a thing they always tell you, because in fact, almost everyone in this classroom has got it wrong in a math class because you did not put your ratio in its lowest possible terms.
Oh, like simplify it.
So yeah, if you had 25 over 100, but 25 over 100 in math is not the proper way to list that. That's 1 over 2.
Never done the moon.
1 over 2.
25 over 100?
It's 1 over 4. 1 over 4.
20.
25 over 50 is what my brain said.
You just
My mouth said
humiliated
something different.
yourself in front of all of the company's chemistry fans. We just got betrayed.
At least we're listening.
That's good.
At
I
least it's
love
called
it.
compass chemistry, not compass
That's
math.
wonderful. That's wonderful.
He was testing.
The point is that you must have your ratios in lowest terms, and chemistry is no different. And again, I do like that you're listening. We always put the positive ion first, which means guess what will always be first in these formulas?
The positive ion.
No.
You just said that's what we put first.
Yes, it's true, but no, that's not the question. If the positive ion is always first, then this is going to be first.
Ammonia.
The metal. Whatever the metal is, better be first because it's the metals that make the positive ion. There's only going to be one exception to that, and that is what? And we learned that yesterday.
Say it again.
Copper. Ammonia.
Salt.
Yeah.
Salt.
It's ammonium, not ammonia. Two different things.
Ammonia. Ammonia.
And we got to be careful. In chemistry, a name, there's a lot in a name. Ammonia is NH3. That is not an ionic polyatomic ion. Ammonium is NH4, and it does have a charge.
Oh, yeah.
Okay.
So yes, only your ammonium salts are the only ones you're guys gonna ever see that don't have a metal first. So you're always gonna put your metal first. Word to your mother. So let's do aluminum oxide. Metals often react with oxygen. Aluminum is just another metal that can.
Boom.
And somebody give me the Lewis dot structure for aluminum. Aluminum is in group 13, so it will have 3 Lewis dots.
What if it was in
I'm
group
very
three?
happy with that.
Aluminum-
Is that
Yeah,
in
what if it was
there?
in group 3? It would have
Yeah.
23 dots.
Yeah.
All right, oxygen. Remember, we add that IDE ending. So oxygen would become oxide in this compound. So what is oxygen's? And it would be 6 valence electrons.
Whoa.
And so here's what we can start doing. We can start seeing that oxygen is, we know that the metal has to have no dots around it in order to be happy, correct? But we also know that the oxygen wants to have 8 dots around it in order to be happy.
Go and move too.
Well, we can only move 2.
Yeah.
Very good, Junior.
Thank you.
And now oxygen is very happy, but aluminum is still saying, wait 1 second.
Wait a minute.
You're got an octet and you're happy, but I'm not there yet.
Do
So,
you add another oxygen and have one?
yeah, we're gonna, remember, things don't just, especially with oxygen, oxygen's readily available. So let's bring another oxygen atom in. We know that it has 6 valence electrons.
What if this one has like?
And then aluminum says, all right, now I'm fine. Now it's got no dots left around it. It has an octet, but we still have an issue.
Uh-oh.
The issue is that this oxygen is now a 1 minus ion, but being 1 minus for oxygen is not happy. It likes to be 2 minus ion to get its octet. So what do we need to
Another
do?
aluminum.
Well, need another aluminum. Now we do know that aluminum, the normal atom has 3 valence electrons, and as you can see, that will make this oxygen now happy as a 2 minus.
But that,
But
that
that
aluminum.
aluminum's not
But now that aluminum
Another
is
So
not happy.
another oxygen.
But I'm hoping you can see with this oxygen, there are 2 open spots and 2 open electrons. This should be pretty happy.
Hopefully.
And guess what?
Happy.
It is.
Yay.
Everyone now, the 2 positive ions are going to have no dots around. That means that has an octet. And each of the oxygens will have 2 dots around it. They'll go to a 2 minus charge. That means for aluminum oxide, this is the ratio that makes everyone happy. What is the ratio here?
2 to 3.
Al2O3. And guess what its formula is in the world? That is its formula.
Wow.
In other words, when we use ionic compounds, we're going to use the empirical formula. We're always going to use the ratio. We all know, I hope you know this. I hope you know this. Because we've talked about the size of atoms. When you have that pinch of table salt, it is not 1 atom of sodium and 1 atom of chlorine. It's billions upon billions upon billions. In 1 pinch of salt, there are so many atoms. Don't worry, we're going to actually calculate the number of atoms that is in like 2 grams of salt. You'll easily be able to do this. But the problem here is that there's no way that's going to be what we list as its formula. No one is going to sit here and go, oh yeah, it is Na, I don't know, times 10 to the 22nd.
Minus 8.
Cl 2 times 10 to the 22nd. So you're not going to do that. Plus, if you change the amount of sodium, guess what you've done? Change the number of atoms. So we never do that in chemistry. What do? Well, we know this. For NaCl, the ratio is always 1 to 1. So that's its chemical formula, even though there's a lot more atoms there than that. Now, we're going to find out that's not always the case in certain things, but that's how we represent ionic formulas. Now, here's the question you're going to actually, well, I'm hoping you're going to ask. Do we have to do this for everything? The answer is no.
Yay!
There is a way to do this, but this, by the way, this is the concept.
Okay.
This is what's going on. But there is a way to do this a lot easier. It's called the crisscross method
Oh.
for ionic compound.
We should put a paywall here, and only like subscribers or like Patreon members or something can like.
Well, that's kind of how it is. It is a private. Only people
But now you have to make it only people who pay can watch the rest of the video.
with the link. Well, it is. You guys pay good money for here, man.
I think you should pay more.
I don't.
Imagine.
He's saying you should make it public, but it's a paid public.
Well, that's not my, that's Compass's. If they want to do something like that down the road, then first of all, they'd have to up their video game, number one.
Bradley and I are
Two.
great photographers.
And two, they have to make that decision whether they want to do something online. But it is possible.
Yeah, I can see them doing it.
So the crisscross method, as you're writing it down, it says it uses the charges and they are crisscrossed to the subscripts. And like with any ratio, make sure it's always in the lowest terms. Again, that says uses the charges and they're crisscrossed. I'll show you how that works. Always in the lowest terms. Sophia. Ooh, we're in the really important example part. But you're like, it's on video, so I can go. Sure.
It's like a set. If she comes back, I can go for my own.
You don't have to wait for her to come back.
Thank you.
I really hope you're using a different bathroom.
I know.
Okay.
Sorry.
I don't know, maybe other teachers only let students out one at a time.
Yep.
But I mean, I guess that's.
But since we're right there, it doesn't really matter in this.
I mean,
class, which-
again, I do have the advantage of being directly beside the bathrooms.
So you can just send students away all you want. You can just be like, go ahead, go ahead, go ahead.
Well, I try not to do that. All right,
Try.
so
Doing it right now.
I'm going to use the crisscross method.
Everybody's gonna try.
Here's what I know from the periodic table of elements. And by the way, you're going to be given a periodic table of elements that actually has these charges on them, which is really nice. But we don't need that resource if we have followed along. This is in group 13. It has 3 valence electrons, which means it's going to want to get rid of how many valence electrons?
3.
And that means it will always form a 3+ ion. Oxygen is in group 16. We know it's a nonmetal. It will gain how many
2.
in order to get 8? All oxide ions are going to be 2-. And if you notice here, I can now take the number. Guys, charges are not in subscripts. Okay? So get that in your brain. When we do chemical formulas, there's never charges. So you just take the number, that becomes aluminum's subscript. Take the number, that becomes oxide or oxygen subscript. So this should be Al2O3. Make sure it's reduced in its lowest terms, which it is. And if you notice, that is the exact formula we got from doing the actual chemistry behind the scenes. And
That's
that
so
works.
easy.
It works every time.
That's interesting.
Yes.
What if I wanted to add like
What if I wanted to supplement
5
water?
electrons to aluminum instead of
You're not going to do that because metals, due to their ionization energies, electron affinities, all the things we discussed in the last lecture, metals are going to be atoms that like to surrender their electrons. They're not going to be wanting to gain them. Can you force aluminum to try to add them in a lab situation? Maybe, to get 8. And there probably will be some level of stability when it does that. But on Earth, aluminum will gladly give up 3 before adding 5.
Okay. So, how do you know how many
Look.
electrons are outside of oxygen?
Well, it's in group 16, which there's 2 ways we can do it. One was the easy way that I just gave you yesterday. The group number tells you the number of valence electrons for the S and the P. Group 1, all have 1. Group 2, all have 2. Group 13 have 3. Group 14 have 4. Group 15 have 5.
Why not 15?
Groups, they don't have 15 because we know the D operates at a lower energy level.
Oh yeah.
So that's the other way you could figure it out.
What about group 3?
Through their electron configurations. Group 3. What is group 3?
And the D.
Remember,
block.
the D block will have various, many of those can have various ionic charges. And so we're going to go over how we do those, but we already kind of did in our notes. The charge is going to be represented by a Roman numeral.
Oh, yeah.
Oh yeah. That's
So let's just do another one of these and see how it works. Let's do magnesium oxide. Magnesium is where?
2.
Group 2. So what is the ion it's going to want to form?
-2.
-2? Very good. Magnesium is always going to form a +2 ion. Does everyone know where Jack got that from?
Oh, it's
No.
Group 2.
It's in group 2. It is a metal. It will lose those 2. And magnesium will then be happy and look like neon.
Is it the valence?
Oxygen, we already know because we've used oxygen numerous times. Will its ion always be?
2 negative.
Now notice this one. I take the 2,
Wow.
bring it down, take the 2, Mg2O2. Well, that of course would be wrong.
Sorry.
It would be
Aw.
a -2, +2.
No, we don't bring the charges down. Why is it wrong?
Because they're the same number.
Because it's a 1-to-1 ratio. The formula for magnesium oxide is MgO. So make sure we reduce them in their lowest possible terms. Because if we did the chemistry behind this, we could easily see that. In other words, here's Mg with its 2 Lewis dots. Here's oxygen with its 6 Lewis dots. And you can see, oh yeah, these guys are going to be really happy. Just give there, we're done. 2 minus, 2 plus, 1-to-1 ratio. But the crisscross method will get us there a lot quicker without having to draw all these dots. Why? We just go ahead and bring the numbers down and reduce. Done. Excellent. Let's do another one. Well, let's do one from the D block there. All right, let's do iron, Roman numeral 2 oxide, since we're all on this oxide stuff. Well, you don't even have to look at the periodic table for this one because we've done oxygen so many times. We're going to go iron. Why don't we have to look at the periodic table? Because the Roman numeral gives you its charge. And we've done oxygen so many times, and you're going to do oxygen so many times. Hopefully you understand when it's in an ionic compound, it's always 2 minus. It's another 2-to-2 ratio. So iron 2 oxide is what?
FeO.
Correct. That is a form of rust, by the way.
It's a DLC.
Oh, let's really throw the old curveball at you.
Oh.
Copper.
Let's do this. Instead of iron 2 oxide, Nitride.
Oh,
Let's go to iron 2.
I tried.
Hydroxide.
Oh,
Oh no, what do we do now? Well, we know iron's charged, that's no problem. Hydroxide, oh, we should know that now. Granted, it is not next week yet, but hydroxide is the OH ion, and it has a -1 charge.
Is it 2 to 1?
So, it's going to be, take the 2, and we're going to be careful how we do this now. And of course, here's take the 1. We don't put 1s down into chemical formulas. How do we do that we have 2 polyatomic ions? Well, here's how you do this. You've got to make sure you are telling the reader that you have 2 OHs. So we would put it in parentheses, and then we would put the 2 on the outside. That actually means 2 hydrogens and 2 oxygens.
that makes more sense. I was thinking something
Now,
else. Okay.
if you were to write it like this, FeOH2, it is very wrong. Why is it very wrong? Well, it's not even the same number of atoms. 1, 2, 3, 4, where this is 1, 2, 3, 4, 5. So this doesn't even exist on Earth, whereas this is the proper salt.
We
So
make that
now-
exist on Earth.
Now we're going to go, oh my gosh, these polyatomic ions, I have to understand if there's more than 1, I have to put them in parentheses. And so now what we can start doing is really, we can start writing formulas for all ionic bonds in all the world. And guess what? That's what we're going to do now.
Wait, all of them?
Yes, in the entire world.
Oh.
Believe it or not, because here's the beauty. Other than the polyatomic ions that you don't have memorized, the periodic table is all the ionic compounds you can have in all the world.
Or all of Earth. Right.
So you guys know what you're
Earth
doing.
is the world.
No, Earth is not the world.
Our world. So it's the
Earth
world.
is not the world.
It is not.
The Earth is the world, the end.
No.
It's our world.
All right. So what you are currently being given
How do we do that?
is a worksheet that has, I don't know, a good amount of ionic compounds on it. Let's go very quickly and ignore the top box. I'll let you guys do that on your own. Oh, you're so kind. All right, so let's start going through this. You guys tell me what to write. All right, so number 1, you guys tell me what to write. And also, here's what I'll do for you guys. I will very quickly.
Take it easy. Take it.
Yeah, get a good list of them up here. Look at all them things. I told you I didn't show you. I only gave you a handful. Say, thank you, Mr. Lesniak.
Thank you, Mr.
No. The 7 you need to know memorized are there. If I give you any other ones, I will actually give you the formulas. All right, so let's do this. You tell me what to write. Number 1.
Copper.
What's the charge?
2. What?
Chlorine. What's the charge on chlorine or chloride?
One.
Huh?
7.
Well, there's 7 in it, so how many does it need to add?
6.
So what's its charge?
Oh, 1 minus.
Cl 1 minus. All right, so take the numbers, not the charges. A 1 will go here, the 2 will go here, copper, 2 chlorides, formula should be this. Well done. That is correct. It is reduced to its lowest possible terms. Yes, Elijah.
Can I use the bathroom?
Quickly. Number 2, you tell me what to write. Lithium, find it on the periodic table. What is
in group 1.
I don't know why you're looking at that table.
Lithium. Li.
Li is group 1. What will its charge be always?
Plus
+1. Very good. Acetate.
That's a fun one to find.
Now that one is on that list because acetate is on your list though also. So you need to remember it. Does anybody look in your notebook and find it? Now remember, I'm not going to give you acetate, so you have to know this one.
It's in group 17.
No.
Yeah.
HC2, H3,
What?
O2.
Right here.
Okay.
It's a compound. This is acetone. Oh, acetone.
Oh.
That's not acetate at all.
85 is acetone.
So 1, 1. So will I need parentheses in this one?
No.
Nope. LiHC2H3O2 lithium acetate.
That's gross one.
It's not that gross.
Oh, it's really.
All right. Vanadium 3 selenide. All right, you guys give me the.
Where's vanadium?
Where's vanadium?
Vanadium. I'm
What-
looking.
What number we got?
5.
It's in group 5. It's
23.
but again, knowing that it's number 23 is fine. But to be perfectly honest, we didn't have to really look at the periodic table other than for its formula, which is V, because the charge is given. What is the charge? 3 plus. And then it says seleniide. Seleniide is the ion of selenium. Selenium is found in group
16.
16, which means it will always be, sorry, it's going to be the same as oxygen. Se what?
-2.
It is always 2 minus.
Or, yeah, I think.
In group 16, it will add 2 electrons. The 2 comes here, the 3 goes there. B2, Se3. We are rolling.
Yeah, I'm liking it.
All right, you tell me what to write for number 4. Manganese is Mn. It's always going to have a 4 plus charge. Well, it's not always, but here it does, because we see the Roman numeral. And then nitride. Nitride is the ion of nitrogen.
So N3 minus.
It will always be N3 minus. That one will always be N3 minus. Very good. It's in group 15. To get to 8, you need 3 more. Mn3 and 4. That does not reduce. That is manganese nitride. Manganese 4 nitride.
I'm liking this. I know how to do it.
I'm liking this. Beryllium oxide. Where is beryllium located?
Group 2.
Group 7. Oh, wait.
So its charge will always be? It's found in group 2.
2.
Always going to be 2 plus. And it says beryllium oxide. We should have oxide pretty much memorized by now.
2 negative.
It is always 2 minus. Uh-oh. This is one of these 2 to 2s.
BEO.
BEO.
Theo gave me a whole rundown.
Make sure we reduce to the lowest terms. Wow, this is almost like we know what we're doing. I like it. I like it, I like it, I like it. Ah. Ooh, oh, let's do one more, because it brings one of these polyatomic ions in here. Sodium sulfate. Sulfate is one you need to know. Na is in group 1, so it's always what?
Plus 1.
Sulfate. Do you have it memorized? Probably not yet. SO4 2 minus 2 1, so we're not going to need parentheses. Na2 SO4. Well, let's get to one where we need a parentheses. Uh-oh, we got one of the polyatomic ions that we don't need to know, or is that arsenic? That's arsenide. So that's NID. So that's arsenic's ion. That's not a polyatomic ion. I erased it. Sorry, you can do it.
It's okay, it's recording.
Arsenic.
Found it.
Very good.
Row number
So we got
7.
aluminum. Al is always going to be what?
4. 5.
3.
2.
3.
1. 6.
Three.
Plus minus 2.
What group is it in?
Metal.
13.
13. It's obviously a metal, so it's going to lose those 3 electrons. Aluminum's the example we used numerous times already today. Arsenic is in group 15. How many will it
Arsenide.
add?
3.
It's arsenide.
Arsenide is the ion of arsenic.
Oh.
Remember, you drop the ending and add IDE. That's why we've said chlorine, no, chloride. Oxygen, no, oxide. This is a 3-to-3 ratio. ALAS. Oh, chromium 4 cyanide. Well, now I want to get to this one. Cyanide is on our polyatomic ions. And so we've got to find cyanide. Cyanide is a C and an N combined. It has a -1 charge. Chromium, we say it's 4, so we know it has a 4+ charge.
It's 6.
Cn-1. Again, this is a polyatomic ion I did not give you to memorize. Does that say 6?
Yeah,
It's
6.
6.
Chromium 6. Oh, that's a big ion, huh?
You said it's always 4 though.
Do we skip 9?
No, I didn't say that. It's got a Roman numeral 6. So now that means 6 has to go here. A 1 goes here. This is definitely one of these where we have more than one polyatomic ion. This is Cr. The polyatomic ion cyanide is in parentheses. And what is the subscript outside? 6. You are correct. 1-to-6 ratio is lowest terms. That is chromium 6 cyanide. All right. I'm feeling fairly confident
We got
that you guys have got this.